Okay, so let's look at some examples of actually using the chain rule. So if we need to find the derivative of x squared plus 1 to the fifth power, we don't want to have to multiply this out. We don't want to have to do the product rule with 5 terms. So what we're going to do is we're going to use our chain rule. So y prime is equal to the outside function here is raising it to the fifth power. So what we're going to do is we're going to apply the power rule. Okay, so we bring down the power. We keep the inside function exactly the same and subtract 1 from the exponent. Okay, so that's just our power rule as we've been dealing with it. Okay, times the derivative of our inside function. So the derivative of x squared plus 1 is simply 2x. And I don't know why it's not writing. Okay, here we go. All right, there we go. The inside function is 2x, so then to simplify, we just need to multiply the 5 and the 2x, and we get 10x times x squared plus 1 to the fourth. So it's already in nice, neat, factored form for us here as well. Okay, and we want to leave it that way. We don't need to do anything else to it. We're done. Okay, let's look at this one. F of x is equal to 4 times 3x minus 2x squared to the seventh. All right, so that constant multiple, just like we've always been dealing with constant multiples, we just leave it there. Okay, 4 times, bring down the exponent, keep the inside function the same, subtract 1 from the exponent, times, now I need to set a parentheses this time because our derivative is going to be more than one term. The derivative of 3x is 3. Oh, that looked pretty rough. Minus the derivative of 2x squared is 4x. So let's fix this up a little bit here. 4 times 7 is 28. Let's bring this term. Typically, we kind of increase powers as we go along. So we'll move that to the front. And then 3x minus 2x squared to the sixth. And we're pretty much finished at that point. Okay, we really don't want to distribute that 28. We really don't want to multiply anything out. We actually can't multiply anything between these two binomials right here. So we're just going to leave it like that. Nice factored form. And we're done. That's our derivative. Okay. Here's another one. Let's look at this one. G of x is equal to the cubed root of x squared minus 1 squared. Now, I'm going to rewrite this one. Okay, I'm going to rewrite this one. Remember how to rewrite powers and roots? Okay, it's power over root. Okay, so this now puts it in a form where we can apply our chain rule with the power rule. So g prime of x is equal to, bring down the exponent, keep the inside the same, subtract 1 from the exponent, and multiply by the derivative of the inside. It's the same thing over and over and over again. What trips people up really is recognizing the outside and the inside sometimes, okay? Now, this one we do want to fix because of the negative exponent and all that stuff. So the 2 stays in the top, the 2x stays in the top. So 2 times 2x is 4x. Over the 3 is already in the denominator. This expression is going to join it in the denominator, and the 1/3 power is the cubed root. So we can put it in like that. And remember, the nice thing about calculus, you never have to rationalize. We can leave roots and radicals in the denominator. Okay, so that's pretty much it. The only other thing you would look for is if you could simplify the 4 over 3, which you can't. So we're good. Okay, let's look at another example. Y is equal to the fifth root of 6x squared plus 5x. Now, there's a slight difference between this function and the previous function. Okay, this entire expression under the cube root here was raised to the second power. That's not the case here. Okay, right here, the only thing squared is the x. So let's be careful. Let's take a second and rewrite this one first before we take the derivative of it. So y is equal to this whole thing right here is under the fifth root. So that's how we're going to write it. We're going to write it 6x squared to the 1/5 because that's representing the fifth root. Plus, and we'll leave the 5x. So when we take the derivative of this, dy over dx is equal to, bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside. So that's all for the first piece. And then the second piece, that's really easy. That's just plus 5. Okay, they like to add stuff on there because when people get caught up in the chain rule, they tend to forget, oh, well, that's just the simple rules that we learned at the very beginning. Okay, so don't overlook the easy stuff. Okay, don't overlook the easy stuff. Now let's fix this up a little bit, because I don't like all these fractions everywhere. So negative exponent, it's going to go to the bottom. So that means 12x is in our numerator. The 5 is in the bottom. Let's go ahead and write that as the fifth root. Hopefully I can get this all in here neatly. You got to put the 6x squared in parentheses, okay, because that whole thing is being raised to the fourth. And then we've just got a plus 5 stuck on the end. And that's pretty much about all you can do. Usually they don't try and simplify the radical, but just as a little review, this probably wouldn't hurt to talk about this. When this is raised to the fourth, you've got to raise 6 to the fourth and x squared to the fourth. So 6 to the fourth, let's see here, I don't know that one right off the top of my head. 6 to 6. Oh, here we go. Let's just try this. 6 to the fourth is, really big number, 1296. Okay, 1296. And when we raise a power to a power, we multiply, so that's x to the 8th. Okay, I don't know. Is 1296 divisible by 32? Trying to simplify this. Let's see here. That's 2 to the 5th. What's 3 to the 5th? I bet that's not going to simplify. 1296 divided by 243. I'm not going to get too hung up in this. I just want to see. Yeah, I don't think it's going to simplify. But as a reminder, we can pull out some of this variable right here. So 5 goes into 8 once. So we would bring an x out, and there are 3 left over. So that is how that would simplify if they did that. And then in that case, we could cancel the x from the numerator and the denominator. They may do that. So just be aware of that. When you do the chain rule, if you look in the answer choices and like that x is missing, just ask yourself, well, was there something under that radical that I need to pull out to kind of simplify things? Okay. Okay, let's look at this one. H of x is equal to negative 7 over 2x minus 3 squared. We need to rewrite this, okay, just like we've been rewriting our rational expressions. We bring that up, give it a negative exponent. So when we apply the chain rule here, remember, keep the negative 7, it's just a constant, keep it, bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside. So we've got negative 7 times negative 2 is positive 14, times 2 is 28, over, I'm getting rid of this negative exponent right here, so 2x minus 3 cubed. And it is easy as that, okay? The chain rule really isn't that hard. People just tend to forget some of the details, and that really messes them up. All right, now this problem right here, it's another one. I'm going to rewrite it, okay? I'm going to apply that squared to both terms. So 4 squared is 16, and I'm also going to do that to the denominator and bring it up so it gets a negative exponent. So s prime of t is equal to, keep the constant multiple in front, bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside, which is 2t plus 8. Okay, so let's see here. We've got negative 32 times 2t plus 8 over t squared plus 8t to the third. Now, something they may do, notice there's a common factor here in our parentheses, so they may pull out that 2 to get negative 64 t plus 4 over, and I really doubt they would do this, but there's a common factor here in the bottom too. So if we did that, notice where I'm putting my parentheses, because when you do that, then technically that t ends up being cubed as well. So I really doubt they would take it this far, but I did want to take the second to point out that factoring, okay? If you pull something out that's raised to a power, then that variable there also needs to be raised to that power, okay? All right, so let's practice with the chain rule. Page 168, 7 through 22.